Alrighty, we're live for APNA Code 2025, day 6 and 45 minutes to go. As usual, we're starting with 2015 problems for warm-up. Let's pull that up. Okay, so we're through 14 problems. Last night, we only did half of day 12, and I wanted to save part 2. So this is JSON. For part 1, we just need to look for all the numbers. Day 12, 2015. Here we go. So this was a one-liner regex. But for part 2, we actually have to parse the JSON. So I thought I'd go for plain old recursive descent without mutation though. So maybe like halfway to a parser combinator. And then maybe later down the line, we could evolve that into like a full state monad driven parser combinator, but we'll at least do it in a functional immutable style that can be evolved. And I think we could do this pretty quickly. The input, let me just check the input. I think the input is just basically strings, numbers, objects, and arrays. Okay. So why don't we make the model that we're parsing into? So we have JSON. Oh no, we don't want Copilot autocompleting that. So we have an object. We have a JSON object. We'll just do obj. And this will have just a map. Call it values map. And the keys are strings, in particular JSON strings. And values are just more JSON. Yeah. Maybe we start with the strings here. So we have a JSON string. Value is represented with a string. Case JSON number. I think we need to hold it in a long because a JSON number could be, not that any of these are long. Just make an int. We can change it if it overflows. Yeah, part 1 we were able to do with int, so this will be fine. So value here's an int, and a JSON array. I'll just store that as a list, list of JSON. Yeah, I think it's just a list of any JSON. Yeah, right. This is a number followed by an object. So you don't have to worry about like a particular type of the list. And then we have a parser. So we have a parser state. Do we want to give it a type parameter? Well, there's input, and there is an index. And we can parse some sort of value from the index we are currently at. So those values could be a string, so def parse string. And then this will return a new parser. But it'll also return the JSON string. Let me think, should state be to, I'm gonna put the state to the left so that it works with unfold. because I think unfold has state to the left. Let me just verify that. Iterator dot unfold. No, it keeps state to the right, actually. The output is to the left. Okay. So this returns a JSON string. And a new parser. And I think you can do some autocomplete here. So parse int, well, parse num, parse array, and then parse object. And parse any value, I suppose. Yeah, that is the main one we need, actually. Okay. Now, how do you go about this? Let's assume that we only call parse string if we've already determined that we have a string in front of us to parse. So basically, parse value will decide which of these subfunctions we end up calling, right? So we look at the piece at 1. Oh, we'll probably want to have like a way to advance white space. So skip white space. And then just like advance some number of indices. Advance cursor. Yeah, I think so. And actually, I don't think any of these need parens. They don't have arguments. So this just gives another parser, turns no value. Um, and then def advance and some number, and then we just get another parser. And we can just implement this. So copy index equals index plus n. All right. So let's look at parse value here. So we want to match on basically the first piece after skipping any white space. So skip white space. I guess this dot skip white space and then no. Let's just assume we start at the start. We can handle. Let me see the input. Yeah, I'm not going to worry about white space right at this moment. So input, we look at the index. This is some character, and we're going to match that. So if it is an open quote, then we can advance one character and then parse a string. Yeah, so we're going to do like this dot advance 1. Let's default this to 1. N equals 1. N equals 1. Or whoops, what am I doing here? N equals 1. So this dot advance dot parse string. So this is our parser state, and this is going to return string and state, JString and state. And I suppose that is a JSON value. So we just return that exactly, the string and that state. And I'm going to have parse string handle the closing quotes. So we don't even need to bind those. So parse num. Well, let me see. Numbers are not going to be in quotes. I think that's kind of like an else case. So we can skip over to list. So this dot advance, and then parse array. And then if it's a bracket, then this dot advance dot parse object. Okay, and these two will be the more interesting ones. And so I guess if it's none of those, then we just default to parsing a number. And we could put the white space skip in here. So case ws if ws dot is white space. Is this dot advance? It does actually have to return a value. So we just advance repeatedly. Okay, that has to happen. You have to skip white space before going into here. So otherwise, we're just parsing number. This dot parse number. Oops. Okay. But what we're probably parsing first is an object. Hey, little Freezy. This is your first appearance this season, yeah? Good to see you. It's been a while. It's been a year. So we're back solving Advent Code 2015, and day 12 involves JSON. So I'm going to spend the first 15 minutes writing my own JSON parser. Everything's been all right. This might be the year that I actually keep streaming after Advent Code, because it's only 12 days and I have to do something for day 13. But yeah, life's been good. It's been a chaotic year a little bit, but otherwise happy. I need to import these classes. So import JSON dot just everything. Parse array is not a member of advanced returns a. Oh wait, we still need to have that. Okay, we'll make it explicit. Advanced one, then parse. You haven't even checked it out yet. Well, basically, Eric's done this for a decade, so he's done 10 full years and wants to just scale it back a bit. It's a lot of work. So from here on out, it's only 12. Also, there's no more global leaderboard. So he doesn't have to handle that headache of, verifying that the people on top didn't use AI. So the end result is everything's just a bit more chill. There's less pressure this year. But yeah, we'll have to do something else to keep the season going. Okay, so we parse an object. So to do this, we need to parse a key and parse the value. What does a key look like? A key is always going to be a string, right? Yeah. I suppose after every time we parse something, we could consume all the white space. I'm not sure when I'll consume the white space. But at least with this input, I don't think we have to worry. Like, this is one line, right? It is literally one line. So I don't think there's any empty white space. So we can leave that unimplemented. I'm glad that makes it easier. Lead code to contests are horrible with all the AI use. Oh, yeah, I didn't even think about that. Oh, that's a shame. Hmm. Yeah, I guess you have to record yourself to verify now. So, parse object. We're basically going to parse we need a parse character symbol. We can define expect. So expect character, and get another parser. So what this does is we basically just advance one. If input at index equals that character, then we advance one. Else we throw an exception. Hmm. Okay, so now we have a key and then new parser state. We'll call it state one because there'll be multiple of these. The code that I'm about to write is going to make it obvious why this needs to be a monad, because it gets a little bit bigger than it needs to be. But we're not going to implement the monad today. So we're going to do this dot parse string, and then we're going to take state one, state one dot expect a colon, and then parse value. So value state two equals that. And I think we want to make this all part of, excuse me, parse kv. So def parse kv. This will return a JString, and a JSON value, just a JSON. And that will tuple it with a new state. Okay. And basically that's key to value, that whole thing to state two. So this state that we're threading around, this value we keep doing, that's what would be held by the monad. And this would basically be turned into a big flat map. So like for, you can put that in a for comprehension. And we just do that repeatedly until we find a closing curly brace. So how do we want to model that? So we can do a recursive function. I know. So some function parse key values and just builds up an accumulator. So we have an accumulator, which is going to be a list of key value. Um, of string and JSON pairs. I mean, I suppose we can make a map right off the bat. Let's just make a map right off the bat. A map of JString and JString to JSON. And I suppose we keep passing a parser along. So state parser. So there's an end case. So if the current value, I need a word for current value. So we'll just call it cursor, or we'll call it current. So def current equals input dot character at index. If current is equal to a curly brace, then we return, where are we returning? We're going to return our accumulator as the value that we're parsing, just paired with the state. Okay, so this function then is just going to be returning the same thing that we're building in the first place. Okay. Otherwise, we parse a key value and then we recurse. So otherwise, val kv and state 2 kv and state comes from state.parse kv. And we recurse to that. So parse with this new s state and act.updated. The keys are key and values are value. Okay, and then we also have to expect this curly brace. We need to advance. So we're going to just do an advance 1. Alrighty, I think that will do us. So now we parse from this state with an empty map to start. Okay, so we can now parse an object. And now to parse an array, it's going to be kind of a similar thing. So def parse will do a tail recursive thing. We have state and an accumulator. And did I choose to represent that with a list? Let's make it a vector because I'm going to append to the right. So accumulator is going to be a vector of JSON. Oh, hold off. Before I finish that, you have to fix an implementation. This thing's not actually returning JSON, it's returning a map. So ACK needs to be wrapped. So it's going to be JSON or JSON object built from the accumulator. Yeah. Okay, and we do something similar here. This is returning the same type as outer function. And I'm just going to copy paste this and change it a little bit. Okay. So instead of a JSON object, we have a JSON array of these values. And what we're looking for is a closing brace. I hope there are no strings that have the braces in them. Oh, I don't think we have to worry about that. Not at this point, anyway. Otherwise, not kv, just k and the state, or just v, rather. So state.parse value. And then accumulator, we add to the right, appended the value. And then it starts with an empty vector. Okay, and similar here, we can just do a take while. I guess there's an optional negative. We could use our numbers regex. Let's hold off on numbers for a second. Let's just do string. So take while not. I guess what we want then, I'm assuming there's no escaping. What we want is the index of the next quotation. So input dot index where. What is this variant? So index where the character is a close quote, and starting from our current index. Yeah, starting from a current index. So we'll call that end. And then we need a slice of the string. So input dot slice from and until. So from index and until end. I think that works. I think that's what we want. Let me just double check that. So let's say, we have a string. ALU1. So dot index of the one, of the one character, right? And then we take the slice. I just don't want to have an off by one here. Of 0 until 4. Cool. Yeah, that's correct. So this is our served value. And we make a JString with that value. And we pair it with a parser state that has advance. So it's dot advance. How many do we advance it? The length of the string, we just advance like end minus index. So in this case, end was 4, right? So 4 minus 0 Right, that's the location of the close quote. So we want +1. So we're going to advance and then let's do an expect the close quote. That way that will error out if our math was off. Okay. So now this one, I think it depends on if we start with a negative. So if current is a dash, then we parse numbers or digits. So we have or you know what? I think we always take just at least one. It doesn't matter if it's negative or not. If we're parsing a number, we're parsing a number, right? So it's basically just like this parse string. So this is a j num, obviously, of v dot to int. Or let's put the to int here. Dot to int. So this is index where it is not a digit. This digit. And we don't search from our current index because that might be a dash. So we'll do search from index +1. And then we don't need to do an expect here. Whoops. For the parse number, we don't need to do an expect. What's going on? All right. And I think we have done it. Right? Is there anything else to do? This is a JSON parser. Done in 30 minutes. Uh, let's see if it works. So wait, we have a parser. Oh wait, we need to know when to stop. So we parse value. And I guess you just parse any one of these values, right? You parse a number, you parse a number. If you parse an object, you just parse an object. Cool. So you just parse a single object. So parser, we need our inputs, and then we start at 0. Dot parse value. So JSON. And okay, we do have to have an error. An implementation is missing. Right. So skip white space was used. No. It's this expect. Okay. So we'll throw a proper exception. Throw new exception. Whoops. So we expected character at index. And then we found whatever current is. Okay. Expected a colon at 3, but we found a. Um, 0, 1, 2, 3, colon. Interesting. Input at index. This is going to give us the character, right? And we are indeed supposed to expect a colon at 3, 0, 1, 2, 3. But instead we found current. Oh, Zara, hey, how have you been? It's been a year. You just realized after today we've already done half the puzzles. Yeah, I know. It has been nice. It has been nice, and we'll have to figure out some other way to keep things going after. My thought is for day 13 to start the Cinecore challenge um, that Eric Wastel wrote before adding the code. I don't know how we found an A, right? Like, what's the current index? The current index is 3. There's no A at index 3. Input that character at. We can change this with current. Okay. You do still get the same error, right? Expected a colon at 3. We found A. We found current. Current is defined as input that character at our current index, right? Our current index is 3. What? How are we getting an A? Is it a one-day thing or a big puzzle? Yeah, it's like 2019. I think it takes about 8 hours to do, so I'll probably make it a multi-day thing, maybe 3 parts. Um, it's not, well, it is multiple puzzles. All you have when you start a puzzle is a blob of binary output and then a text file explaining what the machine code is. So in that sense, it's one puzzle. You're just kind of decompiling that binary output. We have 5 minutes left, so I might not debug this by then. But I wrote a broken JSON parser in half an hour, so that's cool. That's something. um, okay, so this is happening under parse object. And the first thing we do is parse a key and a value. We parse the key and value. This dot parse string. So we parse a string. Maybe we add some tapping in here. So I think we parsed a string successfully. Dot tap. So how do we do this here? We're just going to do a print line on the next line. Print line parsed string v successive parse string empty space. Oh, interesting. So that's something. Yeah, I'm gonna drop you a link to the Cinecore. So the website isn't up anymore, but there are mirrors of it on GitHub. There you go. And FireTech, thank you for the follow. Okay, I should do smaller tests. So let's say you have a parser of I don't know, let's just do a number. Dot parse number. Oh wait, we need an index to start at, so that defaults to 0. Number format exception for an empty string. Okay, that's helpful information. And since our number and string are built similarly, it probably has the same issue. So we're slicing from index to end. Index where it's not a digit starting at index plus 1. Hey, yep, that is your mirror. Brad Tech, glad to have you here. I assume you're also doing admin of code. So parsing a number. The issue we're having right now is that parses nothing. Yeah, so this value, this input.slice. So let's do a print line. Wait, no, not there, on the number. Print line, slicing input from index to end. And what are we getting there? Oh, typo. From 0 to -1. Oh, wait, there is no. Okay, so if it's -1, then it should just be the end. Sure. I think I want to just pipe that. Dot pipe. If I is equal to -1, then input dot length. Else I. Okay, so that should fix that. Cool. Let's try parse a string. It is almost time. In fact, my alarm's going to go off in 5 seconds. Ice Cold Witch, hello. Sparkly Dark. Michael PC Gamer, good luck, everyone. We can debug this later. By the way, happy with my day 5 refactor. This is all my code for day 5 now. I mean, of course, there's my custom interval type. So we'll save this as a day 6 worksheet. Yeah, thank you. I'm happy with it. Oh, I want to tell you about this Jane Street thing later. Someone posted in Discord, Alex. All right, 1 minute to go. You're gonna make a library for solving AOC 2025 day 5 specifically, and have one line of code and say that's my refactor. Awesome. That's how it's done. Every solution can be a one-liner if you library it enough. All right, Sino. Good luck to you too. And here we go. Day 6. So, trash compactor. We helped the elves in the kitchen. And we jumped into the garbage chute. We're in a garbage smasher, very Star Wars. We're approached by cephalopods. Sounds familiar. Right. 2021 day 18 specifically. We can pull that up later. They can get the door open, but it'll take time. While you wait, they're curious if you can help with more math homework. Okay. Cephalod path math doesn't look that different from normal math. Okay, added or multiplied. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. Okay, the numbers are arranged vertically. At the bottom problem is a symbol for the operation. So you what transpose and then, oh, I've got this. I've got this. So val numbers equals input.collect. And what's this going to be? This can be a 2D vector of int. I hope, and I'm just going to go to long. Vector of long. And I'm just going to parse the grid of numbers. We're going to skip this last line. And then what we're going to end up doing is transposing this grid. And then taking each line and reducing it with the operation. So we have a line, and it's just input dot init because we don't want to do this with that last line. And the spaces, no, that's day 2 input. This is supposed to be day 6 input. Okay, so line dot split, and we can do a white space string. I think that's that. That do vector. And map all of them to long. Nope, we have an issue here. Oh, 2 vector on the whole thing. Okay, input string. We're just going to do flat map to long option. Okay, and then val operations. We'll just call them ops. So input dot last, and we're going to do the same thing. Split. Just bring a split on single spaces to vector, and then flat map, not flat. I guess we filter, not filter, not empty. And right, we have a list of operations. So ops, we're going to zip that with numbers.transpose and map each. So case, let's say we have a star and nums. You do nums product. And you want the sum of all of those in the end. And case plus and nums, and we take nums.sum and dot sum at the end. And there's our answer. I hope. Oh, let's just map dot head. Okay, just to get the character. Okay, we have an issue. Let's take a look at the numbers that we're parsing. Let's get the length of each of these. So numbers.map.length. Dot distinct. Let's make sure they're all the same length. Oh, we didn't parse any numbers. So numbers for each print line. Yeah, okay. Let's just split it on a space. Okay. Numbers.map length distinct values. Let's make sure they're all the same length. Yeah, they're all 1000. Cool. Oh, great, and we have our answer. 709806546. Why am I typing this? 0541. Cool. Part 2. Okay, reading the problems right to left, one column at a time. Oh, wait, no. When they see your grand total doesn't match what they expected. So cephalad path math is written from right to left columns. Each number is given its own column. Most significant digit at the top, least at the bottom. So the rightmost problem is 4 plus 431. Wait, what? Plus 623. Each number is given in its own column. Oh, wait, so 4, 431. Okay. So columns. Now columns equals numbers.transpose. And for each column, we're going to need to get the numbers from it. By aligning right. I mean, we could just take the first digit off of each of these, right? And then we go bottom to top. Okay, so we'll make these strings. with some padding. I think we'll need padding. No. Okay, so these columns go from top to bottom. We're going to reverse. Top to bottom and reverse. So columns.map. So each of these has a bunch of strings. So for each column, we then, I guess, transpose it. Call.transpose. And then for each of those, we make string. And then turn it into a long. Okay, and then now we take this bit, so ans2 is going to be ops zip nums for part 2, nums2. Okay, I think I've got it. Maybe not. You can't transpose. Okay, so these numbers that are inside first have to be turned to vectors. Columns.map got toString, and then I guess we don't need to turn it to a vector. toString.toVector, sure. And transposing is going to fail because they all have to have the same size. So we're going to make string, and then we're going to strip the white space. Strip trailing. So toString with padding. Format number with white padding. Scala. And I suppose we need to make that its own function. So well, just inline it in here. So we're going to map. We have some number. Currently, that's our implementation. Okay, so we're going to do this. S, and we take N. We need to know what the longest one is. So val length is going to be let's get the strings here. So val strings equals call.map dot toString. Or, you know what, let's just do some safe padding. Let's just do like 10%. Oh, wait, there's a pad2 method. Okay. And dot toString dot pad2 100. Why not? With white space. Cool. We probably don't need white 100. Let's do 10. Numbers aren't going to be that long. Number format for expression. Oh, well, we want to strip the leading, I suppose. Let's strip leading. Or I suppose just strip. And I suppose we want to filter out empty strings. Not filter, not that is white space. I think we just want to strip everything. So let's strip everything first. We make string, we strip. Yeah, we're just going to too long option and make this a flat map. Okay, now we'll do it. That should do it. Alrighty. So copy worksheet output to Scratch. Not the right answer. Okay, so something is still slightly wrong. So we get the columns with the transpose and reverse so that they are in the right order. We could take like a column to numbers function. Well, let's test this. Instead of columns, it'll just be one column. So vector, vector. And it will just be 314, 23, and 64. Let's see what that turns into. So we get 4, 1, 3, 4. Oh, it goes from top to bottom, 4, 3, 1, and 6, 2, 3. So we need to take out this reverse. Right? So basically this will be 64, 23, and then 314. And now that gives us the right answer, 326134. Wait. That's still the same. There we go. I thought it said bottom to top, like most significant was at the bottom. Well, whatever. I think we've got it now. Oh no, we have another wrong answer. We have officially triggered the timer. Let's plug in the example and see what's happening there. So day-06.text for 2025. And we say that as example. Okay. And we change our input here to, oops. Okay, so for part one, the example was, that's correct. So we're doing something correct. And now let's look at our nums2. Nums2 for each print line. Okay, so we have 623, 431, and 4. Um, and then 532. Oh no. I see. The alignment in the original file matters. Okay. Okay. So all that white space. So this whole original parsing um, of numbers. So that's just numbers one, and we can't reuse that. All right, you snails. Um, Basically what we could do here. Yeah, stripping inline input lines by default. Yep, that's why I just realized. That's why I just realized that it is significant here, and we can't strip. I was like by default left aligning them, uh, not realizing that yes, there's a space in front that does matter. Okay, so I realized my error, and I can fix that now. So we're gonna take input dot init dot transpose, and then how do you decide how many numbers go to each problem? So it's gonna be like grouped, sliding window of some sort. Let me just look at my input. So it looks like variable length columns. Yeah. Okay. We're gonna kind of like zip and group by an operation. So an operation takes so many numbers. So the operations, we're not gonna strip the operators either. We're gonna keep taking the white space, and the white space tells us to take another line. Because I think it is even variable length, right? So that's 1, 2, 3, 4, 1, 2, 3. 1, 2, 3. Yeah, so there's variable lengths in there. My feeling of impending dread increases. See our, yeah, Chinese remainder tomorrow. I mean, Chinese remainder is not too bad. That's library code at this point, right? Okay, so val nums2 equals input dot init dot transpose, and then map. So for each of those, let me just see. There could be, yeah, we just ignore all the white space. So transpose that map, and then we have a column, right? So we have column dot filter is white space, and then we make string not too long. Um, and we can group it by zipping those lines with just the operator line. So nums2, well, input.last.zip with nums2. And now I suppose we've still got to chunk it. It's gonna be a fold left. We're gonna carry some state. Fold left. And the state is the most recent op. And the most recent accumulator. So val init op equals well, let's define opline. So opline is just input dot last opline. Init op is opline dot head, and init accumulator is also just going to be the first number. Oh, it's just going to be 0 because we're going to take the sum of all these lines. So init op, yeah, let's just put it here. Opline dot head and 0. All right, so case. Let's say we start with multiply, and we have some number long. No, we didn't accumulate. In the third accumulator. So 0, 0. We can ignore the accumulator, the third accumulator in that case, and this is the full accumulator of everything. Because we're going to add up each line, right? Hmm. I think actually we're just going to get an accumulation of numbers. Whoa, no, not now. So let's just do list.empty of int. And then the current accumulator can be the head of that. And we just like keep adding to it or whatever. Okay, so that is a state part of our and then we have our B type, which is our number. Okay. So in this case, our state then becomes n onto our accumulation list. And then our operator becomes our operator becomes whatever the current thing is. Test. Bye, Deep. Thank you for the test. Aneurysm wasn't that Diffie-Hellman? Wasn't what Diffie-Hellman? Oh, some CRT problem on Christmas. I can't remember. How's the DX with Scala, by the way? Better, the developer experience, you mean? Yeah, better in Java easily. Natty, you're glad you're not a programmer? Got in there by pure curiosity. Yeah, fair enough. Okay, and then if we see a plus, that means we're changing to the plus operator. So we're going to save that in our state. Oh, hold on. The thing that we're zipping, it's an op. Okay, so here is the op and the n. Am I getting this backwards? So this whole thing, character and the long. Yeah, I don't think we care about this op right this minute. And then the character and the long. So this is a character from the op line. So in the case, this is what changes our state. So we have a potential product here, and followed by an n. And this is the case where we change our operator to whatever that is here, and then we make n part of our current accumulation, right? And then otherwise, it is a space. And if it is a space, we take our current operator, and we'll just do another match in that. So op match. And if it's a star, well, we have ACK onto the rest. So we take ACK times n, and we cons that onto the rest. And we carry over our op. Because of the space, we carry over the op. And if it's a plus, we do the same thing here. Okay. And then at the end of all of that, we have a list of numbers, and we take the sum of it. So val hands2 equals that, but sum at the end. Okay, so we'll fix a few syntax errors here. More syntax errors. What's going on here? Found long required int. List.empty long. Oh boy, now what's this? Right, we just want the second list. And we have a double definition, so we can just get rid of that. Oh, wait. No, we did want that nums2. So what's wrong with this nums2? Transpose requires all collections to have the same size. Are they not all padded on the right? Sorry, I'll catch up with chat in a second. So I think I'm almost there. Oh, you're saying you're struggling to understand the hieroglyphs here? Right. So this arrow builds a pair. And the only thing you need to really know here is this is a list constructor, right? So I could do, whoops, I could do 1 onto 2 onto nil, and then that's a list of 1 and 2. And then the rest of these are just tuples. But apparently, not all the input lines are the same length. A little bit annoying. So we can pad right on a string, right? 1, 2, 3 dot pad. Oh yeah, pad 2. All right. So val max length equals input dot map dot length. Let's just look at how many different lengths there are. 14, 15, 13. Yeah, so we'll get the max. Okay. 15. Oh, is it just because of how I copied it? Does that hold for the actual input? Yeah, it does hold for the input. I just want to see all the distinct values. See what I'm working with. So input.init map. So we're gonna pad to max length with white space. Well, oh, there's only that. Okay, then why can't we transpose? Oh, we're getting a number format exception for an empty string. Okay, yeah, that we can handle. So maybe we didn't need to do this. Filter is white space. So if a column is entirely white space, okay, so these are all the columns, then we can't make a string of it. But, oh, okay, that's annoying. There are columns that are entirely white space. That's the delimiter, right? There has to be a column that's entirely white space. Um, This is a little bit annoying because now my offline handling was Not considering that. I guess I can make that part of here if that's white, and then also the line itself is white. Instead of nums2, it can just be input.transpose. And then these ends that we're working with are not turned into numbers just yet. So if it's entirely white space, yeah, these are number strings. Okay, that's a quick hacky fix we can do to this. Hope and fear. we're gonna do it. A quick hacky fix. If it's not quick, we're gonna back out of the hackiness, right? That's how we avoid going into a loop for the next hour. So forget this. Like we could drop. No, we're gonna too long option this. So in the case, okay, in the case where this is none, then we've actually done all the work we need to, right? Already. So we just do op onto the accumulator. That would actually fix it right there. So this, and we can clean up after. Whoops. And then for all the other n, just parse it out as sum. And yeah, accumulator values. What accumulator is an optional? That can continue to be just a list of long, right? Match error. We have plus with none. Wait, this is a none. So this should be matching the first case. Oh, you can have a plus line. Really? You can have a plus line with an empty thing above it? Let me look at this input. Where is that plus line? How do I scroll sideways? No, it doesn't exist. Okay, so there's no way that's parsed as a none. Right? Okay. Right, we're getting a none where we shouldn't get a none. So input that in it, we're transposing. These are all columns. We filter the white space. Like filter not is white space. Yeah, right. There it is. Cool. We have an answer. Very close to our last one, actually. There it is. Got it. Huh. All right. Okay, a little hacky, but we got there. Thank you, thank you. All right, let me catch up on chat. So, Natty, you're saying you're glad you're not a programmer. You got in this stream by pure curiosity, and just that cephalopod math text is making you confused. Yeah, it makes everyone confused. 2020 day 25 was thinly veiled Diffie-Hellman. I don't think I've done that one. The words are confusing, but once you look at the example, it's just that the numbers are read vertically. Yeah. Yeah. If you're trying to read Scala, Scala can be clean. I don't always write it clean the first time. Um, but I clean stuff up in the repo. It's true. The right to left part doesn't matter since the math is commutative. Yeah, that's just them making it more complicated for no reason. Most and least significant digit, it's just the order that you read the digits. Um, right, the most significant digit is the biggest one. But I suppose I see Black Deep explain that to you. Ice Cold Witch, another simple problem today. Yeah, I've been hoping for them to get tougher too. Okay, this did take me 45 minutes, but like, I know what you mean though. It wasn't tough conceptually. And I think I only tripped up because I was misreading it for a long time. It took me a while to realize how significant the white space was. Yeah, thanks everyone. If you go right to left operator at the end, yeah, it doesn't matter. It's helping me catch up to me on the leaderboards. Speaking of leaderboards, let's take a look. I think we are pretty close. You could be ahead of me. You're totally ahead of me. Oh wait, this hasn't updated yet. I'm pretty sure you beat me in past years, no? 2023? Yeah, 2023 you beat me. Yeah, we can be pretty close sometimes. Oh, Merlinorg is on my leaderboard. So I'm always neck and neck with Merlinorg on the Scala leaderboard every year. This year it seems like I'm in the lead with no trouble. Okay, I was sixth place for part two. I was third place for part one. Yeah, I had a long diff today. Today. Here we go. Thane on your leaderboard got 6 seconds solved the other day. Thane. Okay. Thane sounds like a bot using AI. Thane Polson. Let's look at Thane's times. 33. Okay, 8, 19, You didn't do day 1 in 8 seconds. Mm, Like, sure, day 2 was a one-liner-ish, was it? 2025. Yeah. I mean, you could conceivably do that in 19. You can't read it in 19 seconds. 137. Day 4, though. This is very suspicious. What problem was this? Oh, counting the rolls and removing. So for part 1 was just looking for, yeah. Sorry, Thane, but we gotta take you off the leaderboard. It's fun to see it choke. Okay. Wait, still there. Yes. It isn't member my private leaderboard. Oh yeah. Leaderboards have some weird caching behavior today. Okay, so it finally updated, and I am still in front of you. I see black teeth, but not by much. You can totally catch up. Well, I guess I'd have to choke a lot, but you can totally choke a lot. When there are plenty of fast people, if you choke, then a lot of people get ahead of you. Yeah, the leaderboard update times are so much slower this year. You had some around 10 plus minutes from past years, maybe? Fall asleep some night. Social obligations. I have no social obligations. I'm ignoring all my family and all my friends for the whole month. Work obligations, social obligations. All I'm doing is sleep depriving myself. Not gonna happen. I'm too much of a degenerate. Um, okay, I think I want to go back to 2015. And look, I wrote a JSON parser in 30 minutes. It doesn't work, but I wrote it. My priorities are very straight for the most part. Um, okay, so we can parse a number. We are just testing our parser, some test cases. So let's test parsing a string. I don't know. Let's put some garbage at the end. And you know what? Let's try the same here. Put some garbage at the end and see if it still parses that properly. Hold on, let me comment this out and see that parse. Okay, so that parses properly. And what happens when we parse the string? Oh wait, that's parse number. Parse string. Okay, so we got the message. Parse string successfully. Why would you send that message? Okay, you did not parse a string successfully. Oh, parse string v. And let's wrap that in quotes. From So let's say what we're about to do. So let's do it much like this one here. Okay, slicing input from index to end. And see what we get. From 0 to 0. So end is 0 for some reason. We probably have like a flipped Boolean somewhere. So input.index where equals quote. So we could start at index plus 1, but why are we starting from 0? Oh, right, we're starting from 0. We are assuming. So because of this here, so we're advancing before we parse a string. So there's not going to be a leading quote. So the proper test is that. Which means the only way to properly parse a string is to parse value and get the string from it. So I'm not sure I like that design. But that will make that work, right? Let's at least test that. From 0 to 4, parse string is 1, 2, 3, 4. Okay, so that's working. Let's parse a list or an array. So 1, 2, 3, 4, and some string. AA. And then we have a close brace. So we're going to parse an array. Number format exception for input string. Did we forget about commas? We forgot about commas. All right, so parse array. We check if it's closing. Otherwise, we parse a value. Great. And then this needs to expect a comma. Okay. Now let's see what the error is. Expected a comma at 0, but we found 1. After parsing a number? What were we parsing? I need some trace here. So let's put some print lining, some debug. So the first thing we're parsing is number. Let's put that in there. Okay, so parsing number at index. Oh, when it throws the exception, I no longer get my messages. Expected comma at 0. Well, I think we can reason about that. So it's not this dot expect, it's s dot expect, our current state. See, this is part of why. So my approach here is a functional approach, and it's immutable. So there's a parser state that you carry around, but every function is going to return the value, and then the parser state. And this is why it helps to turn. So this is sort of a monad in secret. I haven't actually turned it into a state monad yet. But what the state monad would do is thread along this state kind of invisibly to you. So you don't have to like create state and then continue from that state you just created. Yeah. So s dot expect comma. Oh, it shouldn't be there. So there's this. But when we parse recursively, first we expect a comma. Well, the comma is optional. So we should expect a comma first. So if it's not this, first we do state dot right. So we have to parse a single value first. We have to parse a single value first, and then we get to the place where we expect a leading comma if there's no closing brace. So state.expect comma. There is state in functional programming, just not shared mutable state. It's local immutable state, confined to context. Okay. So parse this. I suppose there might be 0 values. There might be just one value. We can special case the 0 value, I suppose. Yeah, we'll special case the 0 value, but you have to parse at least one value. So val first equals this dot parse value. And then that's first value, and then some state, right? And we pass along that state and a vector of that first value. And then this whole thing, if current equals that, so if it starts with a close, then we return a J array of an empty vector. Or I suppose we could just do parens there. And we take our state and advance it. I'm just going to call it expect. Otherwise, we do all this, and I'm going to indent that. Or state, I guess this dot expect. Okay. Oh, expected comma at 10, but we found interesting. So at index 10, so here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. and then 10, it went into the comma branch. So that should have gone here to this branch, but it went down into this comma branch instead. Right, if the current is that, closing bracket, then we shouldn't need to then this should never happen. We gotta change this advanced into an expect. Just so we get the error handling. I mean, there's no error handling in this version, so this is pretty simplified. Expected comma at 10, but we found a closing bracket. But you shouldn't be expecting comma. Oh, wait. Current is wrong. If state.current. Geez. See how I keep accidentally referencing the wrong state? That's why you want to thread it through in a state when add. Then that prevents that accident from happening. All right, hey, you got it. So JSON array of JNum, JString. Sweet. I'm pretty sure I'm also missing commas in the parse object, right? Let's pull up that problem. Oh, the snailfish from 2021. Hold your applause. We're not quite there yet. Okay, let's take a look at the input. So, oh yeah, I don't know what the separator is in objects. It's just a comma, right? So where's the colons? Yeah. This would generalize so nicely. Like the end game this, if I were to spend like the next 3 hours working on this, then I basically build my own parser combinator library. And then it becomes super concise to parse a parse JSON. And you know what? Parsing is common enough during admin code that maybe I should just make my own parser combinator library as a, as part of my own standard library. I don't import one because I don't want to use imported code. I don't want to use any dependencies for AOC. But had I imported one, there's so many problems that'd be so much easier. Because we do parse structured stuff every now and then. So my object, this has commas, much like the array. So the array is not the cleanest, but kind of has what I need for the object. Basically, we change that. Closing curly brace. Closing curly brace. This just becomes an empty map. And the part that's different is just here. This KV. Yeah, that's the only different part. There's only a tiny part that's different, so that tells me you can generalize it. This dot parse KV, and then map with the first. It doesn't know what kind. Oh wait, this is a JSON object. J object. Z3 is one of the few third-party libraries I'll bust out for AOC. Fair? Yeah. That said, I don't know. I'd like to make my own constraints, like constraint solver library of some sort. Are you familiar with minicanren? So I have ported that to Scala before, not in a nice way, but I'd like to port it and use that for like my constraint solving. It's pretty easy to port. Wait, what parse? Parse should be getting a J object, and ACK is a map of JString to JSON. And this is a J object. Okay. This might be it. No. Expected a colon at 21, but we found A. Let's test our map parsing. I think I'll need to do the triple quote here. Okay, so we have a name. Say red 33, and then green is 4, and then what happened there? Blue is 0. Okay. That should parse as a object. Parse object. Yeah, and then we're gonna get the second bit. No, not the parser, the object. Rolling your own constraint solver sounds like fun and a challenge exercise. Yeah. Here, let me type you minicanren. Minicanren. It's small. There was a book, The Reason Schemer. So if you're familiar with this series, this one teaches now about like constraint programming. So it's like a relational programming language. I'll drop the link in there as well. And then there's a paper about microcanren that also teaches how. So this book teaches you how, and then there's like a paper on minicanren and like the full implementation of that. And then there's like an even smaller one called microcanren. And you could implement that. So I start off with microcanren and forward that to Scala. Here, where's my code? So do you can run how about conscious do squared slash you can run. There's no readme about it. I've given a talk about it. It wasn't that good. I was like super nervous. But there's my implementation. There's some tests in there so you can get an idea. Yeah, it's a really fun side project. Highly recommend. And it kind of like changes the way you think about. I mean, you already do some like constraint programming, So, you know. Okay. So expected a colon at 10. Well, here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why would you expect a colon at 10? So it's like you parsed a string and then didn't update the state, didn't pass along the right state. Where is it? Well, I did it once. So let me check my parse key value here. State 1 gets passed along and becomes state 2. State 2 gets passed along. Cool. State 1, you expect that, and then you parse value. And when you parse value, I assume that works properly if the functions we're testing below it work properly. Okay. State 2. Okay, let's look at our object. So we parse a key and a value, and we take that state and we use it in the next bit. First state is this dot parse k value, right? And that's the state that goes there. Cool, that all looks fine. So we could put a message here. Parsed key to value. At index, move to the new state, state 2 dot index. Okay, that might be a helpful message. Oh, here. Oh, right. So the print lines appear after the exception. So slicing read from 0 to 4. I guess this was for a string. Yeah. So we parse the string read, parsing number at 6. Wow, those are not the most helpful error messages. From 6 to 8. Yeah, we need to remove some of those. They're just kind of noise. So here, we parsed red. Oh, red still has a quote in it. We parsed red to 33. That's 0, and then moved to 8. So that's a success. Right. When we parse string here, I know what's happening. In the key value, when we parse string, we don't advance past the open quote. And I don't like it, but this is a tiny fix just to have it advance. So this dot advance 1 dot parse string in the key value. That should fix it. That should fix that bit anyway. String index out of range. 32. When did that happen? Okay, so let's get more helpful tracing here. So this slicing, let's just put this at the end. So let's say we parsed v at 0 to or at index to wherever we moved to the new state. We need our end state separately. To state.index. Okay, and then we can do that similarly for other things. This slicing file state. Is it cool if you connect with me on LinkedIn? Yeah, you can totally do that. But then you have to do the LinkedIn puzzle games and compete on the leaderboard. Here we go. I do those daily. Well, 3 of them are really fun. My times aren't bad. That's effort. It's 5 minutes while you're on the toilet. Okay. We have the message for key value. I think that's good for now. Now let's see what's happening here. Okay, we parsed red at 1 to 5. Parsed 33 at 6 to 8. And we parsed red to 33 at 0 moved to 8. Cool. So we got green to 4. Nice. Blue. Wait, what's going on with blue here? So green to 4. Blue still has that opening quote. To J num move to 32. Wait, parse 0 at 31 to 32. Yeah, that makes sense. There's no closing brace. That's the issue here. The object has to have a closing brace. Right. So we tried to reference current when we take the when we do the expect, but that right there failed before we could do this exception. Okay, so that's what hit our message. Now we know. Okay, we have tests for all of our things. So this ought to work, right? Yeah, we parsed it. Check it out. Okay, there's still that issue with the leading quotes. And that is appearing here. Let's look at our test here. So green and blue. And green and blue are the second and third key. It's not happening for red because that's the first one. This.parse kv, sure. So we parse string. We advance one and parse the string. We parse kv. Are we not advancing past the comma. Is that what's going on? Yeah, we are missing the comma. State.expect. Okay. State.expect comma. C films. Hello, I'm doing all right. Just working on some ev in the code. A JSON parser. And okay, I think we've got it. This looks good. So we have a perfect happy path JSON parser. As long as we don't give it bad values, we are good. 3 even. Thank you for the follow. So what's the actual problem? So we need to filter. Ignore any object which has any property with the value red. Do this only for objects, not arrays. Okay. And then we get the sum of all the numbers and everything. So we could transform our JSON by filtering out the red. And then we could sum all the numbers. Yeah, filter red. So JSON returns a new JSON. And right, so we JSON match, exhaustive. So in this case, I know for all of these, so we just return value in these cases. It only matters for the JSON object. So we're just going to match in JSON object, and anything else just gets returned. And then we're going to take the values dot filter case. So we have a key and a value. A key and a value. So we ignore the whole object. Oh, wait. We ignore the whole object. Okay. I suppose this is just when we're looking at individual values now. Yeah, so for this object, we wouldn't even go descend into this object in the first place. So our outer one, I guess, could be fine. We'll just assume our outer one is not, because then we would have no problem to work on. So let's say V, if it's a JSON object, and we can handle all the V's later. Or we have J array as well. And then we have our other V's. And then these are the things that get skipped over. So this just becomes K to, we just pass it along, K to E. Now for the JSON object, if v.values, not values, not values, that exists, no, it has a key. So keys that exists. So if there exists, or maybe let's say just contains, then we're going to use exists. A J string, so we could match. No, we're just going to do it this way. So J string, we're going to do contains. It contains a J string value read. So if that, then there's nothing. So here we're mapping over all the values, and we're maybe not keeping some of them. So option dot unless this condition holds, then we just do key to value. This one here is some key to value. It's always going to hold. And JArray here is going to be very similar. I'm just going to put this. No, we'll leave it that way. So a similar thing for JArray. That's v.values dot contains. Ignore any object. Oh wait, no, we don't do that with arrays. Okay, so we don't have an array case. Okay, great. But we do have to recurse. So all of the values have to be filtered. So filter read this value here and this value here. Yeah. And I mean, we could filter that entire thing, but I don't think there's any need to do it at the top. Any other value we don't have to worry about. Great. And then now we need sum. So we can try sum on just the unfiltered to test that works properly. And we should get the same as and1. So sum of the JSON. Every number value from the arrays and the values of the maps. So we can do an exhaustive match. Loopy first with a rate of 11 people. Welcome, welcome. Wait, Loopy fist? How y'all doing? Were you doing advent of code? Knock, knock. Good to see you. So, yeah, we're doing advent of code. We've already finished today's problem. So we're back solving 2015 problems throughout the series. Oh, you weren't doing advent of code. You were learning Python. Alrighty. Well, in that case, I should tell you about advent of code. So this is basically an advent calendar where every day this month, well, traditionally it's 25 days. This year it's only 12. But every day at midnight, a new problem drops, and it's a two-part puzzle. And they range, a wide variety of topics. So like, it'll be a lot more eclectic than like what you might see on LeetCode. Like some of them are, reverse engineering bytecode or things like that. So I've already done today's day 6 problem, and now I'm just going back through day 12. And here we're given some JSON. 2015 was the first year, so these problems weren't like as quirky as they are now. But basically, we're taking some JSON And we have these conditions that we're filtering out. And then we're going to sum all the numbers in there. You saw someone else doing it the other day? Yeah, well, you should do it too. It's a nice way to learn. So I hand wrote to JSON Parser. And it's a little bit more verbose than it needs to be, but it works. And now I wrote my filter function, and I just need to write the sum function. Yeah, for sure. Okay, value contains non-member of iterable. Really? Okay, so we'll do exists then. Um, okay, values.map. Right, I have to flatten this afterwards. Back to a map. And then we wrap that whole thing back into another JS object. So how do we write this differently? Oh yeah, thanks. And you have a good night. So this is a filtered pairs. Now pairs, maybe new pairs. This is going to be a flat map. And we put the new pairs in a new JSON object. Okay. And then now we define our sum method. So we return an int for JString. I suppose we just do a 0. JNum, we just do that actual value. An array, we take the values.map, and we need the sum on each of those. So they're all JSON. And then we take the sum of those. And then similarly here, we take values.values. So the values gets us the map, and then we want the values of that map. .map, and then we send recursively with sum and do .sum. Okay, and if you sum to JSON, it should equal and1. Same answer. Oh, what's going on here? So now our part 2 val ans2 is filter red on JSON, and then we sum that. Wait, we got the same answer. Right. Am I going to do the FPG challenge? Yeah, this one that you posted in the Discord. I think I would like to do that, totally. Let me share the link with everyone here in chat. Yeah, so Jane Street likes to do like a hardware version of admin code. So challenge here is to choose a puzzle and do it in a hardware DSL or some hardware language. But they're pushing you to use HardCamel, which is OCaml based DSL. Scala is actually inspired a bit by OCaml, and I've been meaning to learn OCaml. So like I don't know, maybe I could just straight up do HardCaml in OCaml. But I think I'll only do it for one problem. So as we're going through, I'll keep an eye out for a problem to do. But yeah, thanks for sharing that. That does sound fun. And we have to figure out why we're not filtering. So we look at values. Um, any object. Oh, wait. If this is array, if the value is an object, it does need to be filtered. Right, so same deal. So in an object, we're filtering new pairs, and we skip over any object that has filter red. But we also need to get them out of the arrays. Okay, and this is gonna be pretty similar. So this will be just new values instead. New values. I suppose this is just like a values.filter. I don't know why I'm doing this flat map thing. Yeah. Yeah, let's simplify this a little bit. So we make a new J array dot apply, and we take values dot filter case v, and now if v is an object, we have work to do. And if the object has red, and then in every other case, it's just going to be true. So we keep it if it does not have red. Whoops. What's going on here? After doing a puzzle in Python, you've completed 6 days this year in F sharp. That's also quite fun. Very okay, cool. Yeah, the .NET version of OCaml, or it's the .NET version of Scala. I mean, F sharp to C sharp is kind of like Scala to Java. I've shown up to a couple F sharp meetups, and it's been vaguely on my list too. Fun fact: the very first version of Scala didn't just compile to the JVM, but also to .NET, and then they gave that up pretty early on. Um, let's just say for all, the key is not red. And in that case, we can keep it. And any other value, we keep. There we go. That's much simpler code. We should be doing something very similar here. We'll do it. So values.filter. Let's see. we're going to build a new J object, so dot apply the colon here, and then values dot filter, and it's actually this exact same code here. Except for that K. And then otherwise, we just keep all the Ks and all the Vs. Or wait, we just say true, rather. Filter on true. Default to true. In fact, we don't even need to match. So there's only a condition if it's if we find a JSON object. All right. Today was so fucking cringe. I mean, you know, when you only have 12 days, you do want them to be harder. How was your experience? I enjoyed it well enough. And I enjoyed the other snailfish problem. This one is really fun. I recommend going back for that. How's the star collecting going? Well, we're through 27 stars in 2015, so we're past the halfway point, and I'm trying to get to 50 stars there by the time we finish up this year. So we'll see. I'm on pace, and I think we're just about to finish one here. No, the filter did not work. It did not remove anything. Are we performing recursive descent? We removed our recursion. Okay, so we do filter out things that are if we see an object, we do filter it, but then we also need to run the filter on that object. So there needs to be a map as well, not map, and we need to go recursively. So we're gonna map values, .view.map values, and all of these need to be filter red. .toMap. And same thing here in the array. .map filter red. There we go. We skipped the recursive part. And now let's take a look. If this doesn't work here, we're gonna have to run some smaller tests. Did it run? Okay, so let's filter red some JSON. Parser. So let's do a list. The first thing's gonna be a number, and then we're gonna have an object that has a key with red. So red and a value 2. What's going on here? So that needs to be escaped. Oh, right, the string needs to be. Hold up. Ah, right, it just added an extra quote. Okay, so we have a list that's 12, and then there's an object from red to 2. And that object should be filtered out. So we're going to parse that. Starting at 0, dot parse value. Or I think we want 1. Okay. Okay, so now we have a JSON array of the number 12 and then that map. So we're going to filter red on that. So filter red on that JSON. What are my evaluation times? 1.6 seconds. Okay. I mean, that worked. That worked. Okay. Give me a second. I'll make a bathroom break and then we'll fix this when we get back. All right, we're close. We're almost here. We just need to figure out why this isn't filtering on the full input. So we do filter red recursively, right, on all the values in an array and all the values in the object case. For string and number, it does not matter. Okay, well, let's diff it. Let's see what's happening with our bigger thing. Maybe what we're missing. Well, I mean, we are recursing. We are recursing regardless of what happens, right? Let's test one of these strings. So we'll parse this. So parser of this string starting at 0. So there's a JSON, and we're going to filter red that, and then we're going to sum it. Oh, this is a raw string. Nope, that doesn't work. I guess we have to just add into quotes. Triple quotes, there we go. Found string required JSON. Wait, what? Okay, so this returns a value, right? Oh wait, we need to parse something. So dot parse value. There we go. And sum is 2. Okay, well now here's something we can compare. So let's call this J. And let's compare it with this filtered version. I think I need 2 string methods. So filter red J. Let's do a show. Def show. So we have some JSON, and it turns into a string. We can do an exhaustive match. So JS match. So when we're printing a string, we show the value inside of quotes. And number it just value.toString. An array, we do values.makeString. Well, values.map show. Map show. And then we make string. With open and close braces and commas. There's a code forces round in 1 hour if you don't want to sleep. Lovely. I'm going to sleep after this problem, I think. I think I'm pretty close. I just want to diff J with a filter J. And to do that, I'm first making a toString method. So it's easier to diff on the eyes. Okay, so values.map. This is a little bit different. So we have key value pairs. And I guess we show on each side. So show K. Well, we'll put this whole thing in a string. So we have show of the key, and we have colon, and then we have show the value. And we make string. So it gets wrapped in curly braces with commas in between each. All right. Legal definition of I think we need to indent this a bit. There we go. Okay, so we're gonna show J, and then we're gonna show filtered J. All right, what's the difference? There's no difference. So see, wait, red is a value. Any property with a value red. Am I looking at keys that are red? That's what's going on. Feed at values, keys for all. Okay. Values are values. I see. Values are values. I was misunderstanding the problem. That's why my test looked like it was working fine, because I was testing the wrong thing. Cool. Yeah, we've got it. There's the answer. 96852. 96852. All right. We got it. We can go to sleep. And leave the test code down below. Clean things up later. Thank you, thank you. Yeah, this could use a lot of cleanup. I think one day I'd like to turn this into more of a parser combinator kind of thing. And really, I should have my own parser combinator code for admin code, because it's going to come up again. Yeah, that feels like a satisfying place to end. We only did 1 star from 2015. I guess it took me a while. Half an hour to write and another 2 hours to fix it, to keep writing it. It wasn't that bad. I don't feel like we got all too stuck anywhere. I did want to do maybe one thing. Let's revisit day 10 again. I just want to get this out of the way. And this is our mutable code for this look say sequence. This is the one I spent a lot of time on a couple nights ago. Yeah. And I'm gonna make it. I'm just gonna make it a little more concise. So the essence, the mutable part here that we care about is this right here, or this here. Basically, we are just the part where we append to the string builder, right? So if we can just get this count and head out separately, then we can do all the mutation in like a separate step, shove it to the edge. So what I'm going to do here is an unfold with our state being an index. And the index tells us where to look for the next sequence of identical digits. So iterator.unfold, index state starts at 0. Okay, so we are given our state. It's the index. Let's call it the start. So where we are starting our search. So the current head is going to be look.character at start. And then we still want to get a count, right? So we're going to get the last index look, or rather index where. Yeah, this from. Index where it's not equal to start, or not equal to head, right? But we don't want to look right here, starting from start plus 1. Okay, so this is like our end index. In fact, let's just call it end. There's an edge case for the end of string where it'll be -1. So I'll handle that later because we're just looking for a character that's different, right? So now our count is going to be head until end, head until end. Dot size. Yeah. So our say will be count of head. We return count and head. So this is the thing that we're returning, and then we count it onto our next state. So our next state is just going to be end. Okay. Now this whole thing is optional. We need to know when to end, and that's where this option comes into play. So we'll do an option dot when start is less than the length. Look dot length. Yeah, we can keep searching as long as start is less than look dot length. N becomes a new state, right? So that becomes a new start. And n could be -1, so we're going to match and handle that case. So if it's -1, we're just going to say look dot length. That keeps this math correct, right? Yeah, the index is past that. And otherwise, we just pass that same index, I to I. Great. So now once we have all of those, we just pop them all on we'll call these pairs. Pairs up for each, or we can do this. So count and head, for count and head from the pairs do. We still need a string buffer. So sp equals string builder. We're going to add a capacity. So look dot length times 2. And then now we just plus equals this stuff here. Count that to string and then the head. Oh, let's call that say. And then now we just do say dot result. Okay, so this is the previous version. This is the new version. It's not that much shorter, but it at least separates out into 2 parts where like this is all functional. And is int required a character? Head. Oh, wait. We need the index of head. Oh, this is start until end. And wait, is it running slower now? Okay, I mean it's still running. Let's do this. Val n equals look.length. So all the length. At least make it easier to read. There's a character at start +1. I suppose we could do the math here. It's going to be end minus start +1, end minus start +1. I can just guess and check. No, it's just start. It's just end minus start. Yeah. Um. Yeah, I think I like it better. And the other option is just to like find all the matches of a regular expression. And then for each of those matches, you do a string builder thing. It has more semantics in it. So I do like that about this approach. Yeah, so that's a wrap of that. I think the big one tonight was still doing this JSON parser. It felt satisfying. It feels satisfying to do something like that. And let's find someone to raid. Um, Alka is on. I don't really know if we've rated Alka yet. Oh yeah, no problem. Happy to do it. Thanks for stopping by. So I just want to check that Alka is still on the problem before I go in. It looks like maybe Alka finished. So if you can help me find someone who's still doing it. Bad Cop I rated yesterday, so I want to find someone else. We don't want to rate the same person every day, right? Someone I haven't rated yet. Oh man, are there really only 3 of us doing it right now? I just saw more. Oh, Hextree's doing it. I remember Hextree. Voiland's doing it. We did already raid Voiland. Let's take a look at Hextree. Yeah. And yeah, it looks like Alka did finish. All right, we're rating Hextree. What's my favorite anime? I don't know. I'll have to think about that. But we can chat more next time. Hextree with an underscore. Alrighty. Have a good night, everyone. Thanks for stopping by and sticking around. All right. Let's send it.